Assalamu alaikum wa rahmatullahi wa barakatuh. Students, how are you all? Today we are starting a series of videos regarding quick revision of chemistry. You guys have been through the syllabus of chemistry, and this year you guys will be appearing as well. I told you guys multiple times that beside doing passive practice, it is really important that you must have completed on your syllabus. That means all the topics that are included in your syllabus must be on your fingertips. For that purpose, I have shared your with you guys multiple times. I have shared these quick revision notes with you guys. So I am recording the lecture, discussing all these points quickly. It will be a quick, short revision, and hope it will help you guys. Besides solving past paper, it is really important that you must have all these topics on your fingertips. सारा आना चाहिए, कोई भी अनसीन क्वेश्चन अगर आ जाए जैसा कि पास पेपर में नहीं आया, so yeah, you guys must be able to solve all those questions. Okay, अगर ये सब याद होंगे points, then you have to apply a little bit of problem solving skills, and then you guys can solve it. So, starting with the first topic, which is the state of matter, subtopic of this topic is to state the distinguishing property of solid, liquid, and gases. Solids, they have fixed shape and volume, not compressible, tightly packed. Liquids, they have fixed volume but no fixed shape, slightly compressible. Means मतलब उनके जो compressing ability होती है, that is negligible. ठीक है. So in some books it is written that they are not compressible. Particles are closed but can move past each other. पार्टिकल्स जो होते हैं उसके बहुत क्लोज होते हैं एंड दे कैन मूव पास्ट ईच अदर. अच्छा, gases have no fixed shape or volume, highly compressible, particles far apart and move freely. Then next topic is describe. Acha, uh, if you guys can see, there are command words written over here like state, describe. So it's more likely that in your paper you have, if you have a question regarding properties of solid, then it will be with a command word of state. And then in terms of particle, then they will use the word describe. Okay. If a question आएगा तो उसमें describe कर दूंगा, then you have to write a couple of sentences for that. ठीक है. Statement, you just need to state properties. Okay. Uh, you can just name the properties like fish shape, fixed volume, not compressible. On the other hand, if you have to describe the structure of solid, liquid, and gas in terms of particle separation, then you have to discuss it in a bit detail. Okay. For example, solid particles are very close to each other, arranged in regular pattern, vibrate about the fixed position, and liquid particles close together. Particles are close together but irregularly arranged, moving freely around each other. Okay, they are irregularly arranged. They are close together, but they are moving freely. They are sliding past each other, as it is written over here. Particles close but can move past each other. So again, when you are discussing, describe the structure in terms of particle separation. So you have to describe it. You have to write a couple of sentences on that. Okay. So gas particles are far apart, randomly arranged, move rapidly in all directions. Okay. So next thing is describe and explain the changes in the state of melting point, boiling, evaporating, freezing, and condensing in terms of kinetic particle theory. So you have to study kinetic particle theory, which you have studied already. According to kinetic particle theory, melting happens when particles gain kinetic energy. Kinetic particle theory actually it relates kinetic energy of the particle with temperature of the particle. As the temperature increases, kinetic energy of the particle increases. And solid, as you all know, as we have discussed, particles are arranged in regular pattern. They are vibrating about fixed position. So when melting happens, solid converts itself into liquid. Particles gain energy, vibrate faster, overcome forces. Uh, when it is in solid form, it starts vibrating faster and faster and faster. And when melting point is reached, the particles are transitioning from vibration to sliding over each other. Okay. So for that they have to overcome forces. Okay, which are forces of attraction. So they overcome those forces. We have discussed the case of melting of ionic compound salts, and they have high melting point. And in those cases, we discuss why there is high melting point of salt, because they have a strong electrostatic force of attraction. Okay. Similarly, giant molecular structures, they also have high melting point, because in those molecules they need to overcome the covalently bonded structures Okay, salt is also part of giant molecular structure, but there are other examples like silicon dioxide, graphite, and diamond. So they have a really high melting point in case of graphite and silicon dioxide. It is way more than any compound or metal. Next is boiling and evaporation. Okay, these are two phenomena in which particles they change their state from liquid to gas. Boiling is a bulk phenomena, means that the particles they are changing the phase altogether, and boiling happens at a fixed point, whereas evaporation it happens at room temperature, at any temperature in fact. Okay, evaporation can happen. Okay, so the more the temperature is, higher the rate of evaporation is. Okay? It's directly proportional to the temperature as well. Okay, but it happens below the boiling point. Okay, evaporation always happens below the boiling point. Particles gain enough energy. What is happening in these two conditions? Particles gain enough energy to escape from liquid surface. In liquid surface, they have still have surface tension, and they have small amount of intermolecular forces of attraction, or electrostatic force of attraction between them. Okay, there is force of attraction between liquid particles. So when they turn into gas, there is negligible force of attraction between the particles of gas. Means there is no force of attraction between the particles. Okay. Next is freezing. Freezing is when particles lose energy, move less, forces pull them into fixed position. Okay, and liquid they change into solid. Okay, now over here, what is happening is liquids are in particles are in liquid form, and they have little force of attraction, and they are changing their uh, s- as they are changing their state from liquid to solid, the force of attraction between particle it increases. This is how uh, the forces pull them into fixed position. The force is gained, intermolecular force it increase. Okay, so we have forces pull them into fixed position. And in condensing, gas particles lose energy, move closer together, and gas turns into liquid. Okay, again, there is gain in intermolecular forces. Okay, the gases they have a negligible intermolecular force and force of attraction, and in liquid there is considerable amount of force of attraction between particles. So the force of attraction between particle in freezing and condensing, in both the cases, the force of attraction of particle increases, temperature decreases. Okay. So the thermal energy is converted into the intermolecular force of particles. Okay. The forces of attraction between the particles. Now, coming toward it and explain the heating and cooling curves in terms of kinetic particle field. During heating, the temperature rises, kinetic energy of particle increases. Flat section, okay, and there is a slope, constant slope. Okay, just like this. Okay, there is a straight line, and particles and graph is over here like this. Okay. You have time over here, you have temperature over here. Okay. So in heating curve, uh, the particles they gain kinetic energy, and the temperature rises until and unless when there is a phase change happening. Okay. Be it melting or boiling. Okay. In both the cases, there is a flat plateau. After that, and after the phase change happen, again the temperature starts rising. Yeah, the temperature starts rising. So, uh, flat section plateau show change of state. Energy uses to break and or form intermolecular force of attraction. Break or form means obviously if it is heating curve, then intermolecular forces are breaking. Okay, intermolecular forces are breaking as discussed in point number 3. So, but in cooling curve, the intermolecular forces are forming. Okay, if it is cooling curve, then it is like this. Okay, it's coming down, stepping down. The temperature is going down. So in that case, intermolecular forces are forming. Cooling curves are the reverse. Okay, the energy is released as particles slow and forces are formed. Okay. So in flat section, plateaus, they show change of state. Energy is used to break or form intermolecular forces. And in cooling curves, energy is released and particles slow down. Okay. So heating curve, the first point is regarding heating curve when temperature is rising, and this last point is for the cooling curve when temperature is falling, and it is like this. So temperature starts falling, and then there is the flat area where there is phase change happening, whether it is melting or freezing or condensing in both the cases. And in the case of condensing, this is the gaseous phase, and then this is uh, condensing phase, and then it is liquid. In case of freezing it, this phase is for decreasing the temperature in liquid, and this is freezing phase where liquid is changing into solid, and this is solid phase where the temperature of solid is falling. Okay, so the first one was heating curve, and this one is cooling curve. Now, coming towards the next, it is describe and explain in terms of kinetic particle theory the effect of temperature and pressure on the volume of gas. And we have discussed Charles' law and Boyle's law in this case. Okay. The one is discussing temperature is Charles' law, and the one discussing pressure is Boyle's law. And we have already discussed in detail that there are three, when we are discussing gases, there are three factors which affect the volume and all the stuff of the properties of the gas: pressure, volume, and temperature. Okay. So in Charles' law, the increasing temperature, particle move faster, they collide more strongly, gas expand. So it discuss the relation of temperature and volume. Okay, and in that case, pressure is constant. Okay, in Charles' law, pressure is constant, and in Boyle's law, it is discussing pressure and volume, the relation of pressure and volume, and in that case, temperature is constant. Okay. Uh, Hope you have got this point. We have already discussed in the detail, so it is a quick revision video. If you have to look into the topic, you can go and refer to the book or notes, read this topic in detail. So the next thing is describe and explain diffusion in terms of kinetic particle theory. According to kinetic particle theory, diffusion is the spreading of particle from region of higher concentration to lower concentration due to random motion. So we have already discussed the phenomena of diffusion. Okay, when gases or in liquid, the particles are sliding over each other in liquid, and particles are moving to in all direction in gases. So when there is a new fluid is introduced among a fluid which is already present, so that fluid will move from higher concentration to lower concentration. And we have discussed the coffee example of coffee or any food which is cooking, or there are plenty of uh, other examples as well. So in gases, diffusion is fast. When we compare gases and liquid, the diffusion is faster in gases due to obvious reason, because there is more kinetic energy. Okay, the particles are moving freely and rapidly. So in gases, diffusion is faster. And then the next thing is we have to discuss the effect of mass on the rate of diffusion of gases. Okay. Uh, Describe and explain the effect of relative molecular mass on the rate of change of rate of diffusion of gases. So gases, if they are lighter, they diffuse faster. Okay, and their particle move more quickly. And when they are heavier, they diffuse slower. As in humans, if we have a person which is slim and smart, and he can move quickly, and if a person is bulky, uh, he or she can move a bit comparatively slower. Okay, so similar is the case with all these elements. Okay, when they are lighter, they can move quickly. When they are heavier, they cannot be moved quickly. So rate of diffusion of lighter gases is more faster as compared to heavier gases. That's it for the first topic, which was the state of matter. The next topic is atoms, elements, and compound. We will discuss it in the next video.